So now we're going to take a look at how we deal with more than one table, multiple tables, because the real power of SQL and the power of database performance has to do with when you start connecting tables together. If you go back to that original mathematics, it models data at the intersections between the row and the columns. And these intersections are the magical bits. And so breaking an application to use multiple tables is an art form. It takes a while. There are some simple basic things that you can learn, and we'll teach you here. And so it's not too hard to learn the basics, but then it's much more complex to be super skilled at it. And in general, advanced databases, in my mind, it's hard to teach advanced databases because they're always so contextually grounded. Something like a Twitter or Google, the databases are so specialized. By the time you make everyone can do small to medium-sized databases using the basic techniques, but at some point, once you escape medium-sized databases, you end up in these sort of narrow things and optimize each database very separately. And so I just tell people, learn the basics really, really well, write programs, and then go do real work. But database design is the act of figuring out the data that your application is going to want to store and spreading that across multiple tables. But we don't just do it randomly, we do it very much cleverly. And if you look at a data model, this is what it looks like. And what we're showing here in this data model is we are showing 5 tables, and this is a kind of a calendar kind of a system. And we're seeing the columns that are in each of the tables, and then we're seeing the relationships between the tables. And even in these relationships, there's kind of a little bit of code. And when you have an arrow that looks like that, there's many of those to one, and this is a many-to-one relationship. Many-to-one relationship. We'll talk all about that stuff. But if you go into an organization and you have a really large and complex data application, they might have something printed out on the wall that looks about like this, which shows the database tables and connections, et cetera, et cetera. And they might say, oh, your job is to go down in this little corner and add one field there, and then do this, and then connect it with this thing over there, and then make a screen that shows all these things that pulls from this table, this table, this table, and that table, and that's your job if you're a programmer on a large software development project. These database models become sort of like the core backbone of the knowledge that applications are managing and using. So the idea is that you take your application, we're going to start really simple, we're going to take your application and you have to draw a picture. And the basic rule, and literally you could spend course upon course learning about database normalization, but I'm going to distill it into one basic rule, and that is never put the same string data in twice. So my name, Charles Severance. If I build a database well, you should go into that database and you'd say, okay, the words Charles Severance, which is the name of a person, me, in that database, only shows up once. And what we do instead is we connect things together and model my name as a connection to the record that has my actual name in it, rather than putting my name all these other places. And so the idea is to pull duplicate data out and make only one copy of it. So there is the users, and in there is the user's name, and the username shows up only here, and everything else points to the particular user entry. So that's the idea. And so here is our first application. We are working as a startup. We just quit all of our jobs, and we are going to build a music management application. I mean, what a great idea. Don't you think that'll be quite successful? And so we have mocked up and we have figured out that this is what our music management application. We want to track people's tracks, know something about what artists and albums and genre they are, and we want to have ratings and how many times we played them and how long they are. Well, that's the data that our application needs to represent. And we've done testing on this and wireframes, and everyone loves this, a great user interface. And so this is how it's got to look. But we're going to have billions and billions of tracks in these things, and so we want to come up with an efficient database to handle this. And so we're going to take a look at this and look at each of the columns, and we're going to ask ourselves, is this column part of one of our existing objects, our existing tables, or is this object have to create a new table? And then once we've defined those different objects, we connect the tables together and model the connections. Now, a little trick to kind of make it a little easier on ourselves is we can look in these columns and look in the columns that have duplicate information vertically that's string information. So rating is just a number like 0 through 5. So we don't worry too much about integers and numbers and that kind of stuff or whatever, but we do look for strings. And the problem here is we got like these strings occur many times. And so these are the problems. And so we have to put these things where there is replication of string data kind of in the vertical dimension. We have to put those in different tables. And so we'll start out. Now the first question that you have to ask yourself when you're going to draw this picture of how this data is in multiple tables and connected together is what is the first one that you're going to write down? And this is an interesting debate, and often people are sitting in a conference room and people who have experience kind of know what to do. Usually if it's a multi-user system, like a learning management system, the users might be the central concept. Perhaps the courses might be the central concept. This is a single user system, and so you can think, well, what is really this application about? It's not about people, it's one person, but it is about tracks. And so we can say, okay, here we'll take the track is probably the sort of most foundational notion of this application. And then we can take and say, okay, now that we've decided that tracks are the foundational notion, which of these columns are simply an attribute of the track? Not really, and the cheating way and the easy way in this particular one is like these numbers, all these numbers, like this number and these numbers, not that one. They just go along with track. And so we'll put that in. We got the track title, rating, length, and count, and we put that in. And then the question is, we've got the remaining things are, we've got the artist, we've got the album, and we've got the genre. And so we can say, okay, well, we've got some vertical duplication, so we're going to say, okay, this track probably belongs to an album. So let's pull out the album into its own table. Oops. Pull the album out into its own table. And so pull the album out into its own table. And so that pulls that out, and then you say, okay, what would be the next thing that we're going to pull out? So we pulled out the track, we've got this taken care of, this taken care of, that taken, now we've got the album. Well, albums belong to artists, so let's take out the artist. And then we'll pick where the genre belongs, and we'll just say that the genre belongs to the track. And so, because there might be albums with more than one different genre. So each album is not necessarily a rock album, it could have a rock track and a country track, etc., etc., etc. And so now what we've got is we've got 4 tables, right? We've got a track table, we've got an album table, an artist table, and a genre table. And if we sort of double check, all of the columns that had vertical duplication in them now have their own little table. So we can eliminate, the next thing we'll do is to show how we're going to eliminate this vertical data replication by showing how you represent these relationships that we just created inside of the database.